Pleasant morning to my dear lovable students. I hope you all are fine. In this conversation, we are going to continuation of exercise 1.3. I am moving to question number 5. So, the question, let A is equal to the pair 4 number is there. At the same time, B is equal to their variables, that is letters is there. Give a function from A tends to B. For each of the following, we have to verify. Okay, one by one. The given condition, I am moving to subdivision 1. This is set A. This is considered for set B. This is called A. This is called B. A is considered for 1, 2, 3 and 4. B is considered for A, B, C and D. The first one neither 1 to 1 nor on to. So we have to show not 1 to 1, not on to also. So mapping A to 1 at the same time mapping to also A, then 3 to mapping to B, 4 is mapping to C. The condition, what is the meaning? Neither 1 to 1. We can say no, it is not 1 to 1. What is the meaning of 1 to 1? Each and what is the definition for 1 to 1? Different element of A have different images in B. Here actually the true element have same image in B. That's why it is not 1 to 1. So how to finish a line? It is not 1 to 1 because 1 comma true of set A have associated with the same image B. That's why we are saying it is not 1 to 1. Second condition also it is not on to because so what is the definition for on to? Number of codomain is equal to number of pre-image. Here D in the set of B, D in the set of B have no pre-image in set of A, isn't it? Pre-image in A. That's why we are saying it is not on to. I'm moving to subdivision true. Subdivision true, not 1 to 1 but on to. Subdivision true, set A, set B, 1, 2, 3, 4, A, B, C and D. So the same condition you can draw it like so 1 and 2 have same images in set B, then 3 to B and 4 to C. The condition also subdivision true, not 1 to 1. Okay. So okay, this is not 1 to 1 but on to. The question is but on to. It is not possible. Why? The condition here each and every time there is 1, 2, 3, 4 only is there. You have to show it is not on to, means this is the way. If you have any more than a number of pair in set A, means if it example there is no 5, if you write it 5 means we can say D mapping to 5 means we can say but on to. So why it's not being possible? Number of domain is equal to number of codomain. We have same equal value. That's why we are saying it is not possible. So subdivision true answer, it is not possible. Why? Number of domain is equal to number of codomain. Okay, I am moving to subdivision third. I think subdivision third also same images. So 1 to 1 we have to show, but not on to. So 1 to 1 means what is the meaning? 1 to 1. So 1 to 1 means mapping 1 to A, mapping 2 to B, mapping 3 to C, mapping 4 to D. But here we have to show 1 to 1. This is, we can say 1 to 1, but not on to. Not on to means we have to, what is the meaning? Here also same condition. If we have the more than pre-images means definitely we can say this is on to also. No. What is the meaning of on to? Number of codomain is equal to number of pre-image. Each and every value mapping. No. Therefore, this is we can say no, it is also on to also. So, why it is not possible? The same answer for we can write it subdivision third also, it is not possible. Why? Number of domain is equal to number of codomain. Moving to subdivision 4. Set A, set B, 1, 2, 3 and 4, A, B, C and D. We have to show 1 to 1 and on to. Very simple, no? Direct line, number of 1 mapping to A, number of 2 mapping to B, number of 3 mapping to C, number of 4 mapping to D. Then we can write now. It is 1 to 1? Yes, it is 1 to 1. Because different element of set A have associated with different images in B. Different images in set B. That's why we are saying it is 1 to 1. Next condition. On to. Yes, it is on to, because every element of B, every element of B have pre-image in set A. That's why we are saying it is on to also. Okay, I will continue the next question. Question number 6. Find the domain of 1 by 1 minus 2 sin x. So, all the real values we can say domain except 0. Why I am saying except 0? For example, 1 divided by 0 means it is not defined. No, it is not defined. That's why, therefore, denominator, the whole term considered for 0 means 1 minus 2 sin x is equal to 0. Therefore, minus 2 sin x plus 1 bring it opposite side, minus 1. Again minus minus cancel, then 2 sin x is equal to 1 means x is equal to sin x is equal to 1 by 2. Therefore, sin pi by 6, isn't it? Sin 30 means 1 by 2 now. Therefore, sin x is equal to sin pi by 6. Therefore, sin x is equal to sin pi by 6 means x is equal to pi by 6. Therefore, domain. So, domain means all the real values except, how to make it? Sin x is equal to sin pi means the condition already we have discussed about one question. Cos x the real term, what is the formula? So, 2n pi plus or minus theta, isn't it? Sin pi n pi plus minus 1 the whole power n into theta. Okay. Therefore, what is the formula? Instead of theta, the angle value pi by 6. Therefore, all real value possible except n phi plus minus 1 the whole power n into, instead of theta we have found the answer pi by 6. So accept this answer. Okay, I will continue the next question. So question number 7. Condition: find the largest possible of the real valued function f of x is equal to square root of 4 minus x square over square root of x square minus 9. So already I taught, I think one question, the same question. For any one number of the value in square root means it should be a positive, then only we can say it is a function. Otherwise, if any one of the value square root negative means definitely it is not a real value, only imaginary. Okay, so I will consider for the numerator, take it for p of x. Okay, symbolize, so 4 minus x square, isn't it? 4 minus x square always greater than or equal to 0. So each and every time starting 4 is there. Now starting x square means what we have to do? Each and every time into minus. Into minus means x square minus 4 means inequality symbol also less than or equal to 0. Already you know a square minus b square is equal to a plus b into a minus b. Therefore, x square minus 2 square less than or equal to 0. This is considered for x plus 2 into x minus 2 less than or equal to 0. Then therefore x is equal to minus 2 comma positive 2. Take it on number line. Minus infinity to positive infinity. Center 0. Minus 2 to positive 2. Just arrange the term. First one interval. Then condition x plus 2 into x minus 2. The last one output. Output we can take now p of x. But p of x consider this value. Why? The starting x square only we have taken, isn't it? X square minus 2 square. X plus 2 into x minus 2. Therefore, the condition less than value, isn't it? So less than means first interval minus infinity to minus 2. Close interval open. In between take it minus 3 means consider for only the sign only. Minus 3 plus 2 means minus sign. Minus 3 minus means minus. Minus into minus plus. Next condition minus 2 to positive 2. Center 0 is there, no? 0 plus 2 plus 0 minus 2 minus. Plus into minus minus. Next condition 2 to infinity. So 2 to infinity means 3 we can take it. 3 plus 2. 3 minus 2. Again plus. This is also wrong because you are taken for less than value. Therefore, the first condition p of x belongs to minus 2 to positive 2. Next one, denominator consider for q of x. So q of x is equal to x square minus 9 always greater than or equal to 0. This is directly we can apply x square, instead of 9 we can write it 3 square greater than or equal to 0. Again we can apply a square minus b square form. So x plus 3 into x minus 3 greater than or equal to 0. Therefore x is equal to minus 3 and positive 3. Take it on number line. Minus infinity to positive infinity. Center 0, minus 3 and positive 3. So now the interval x plus 3 into x minus 3. This is also q of x, isn't it? Small of the term, okay, q of x. First interval minus infinity to minus 3. Minus infinity to minus 3. In between minus 4. Minus sign, again minus. Minus into minus plus. Next category minus 3 to positive 3. Minus 3 to positive 3. Center 0. 0 plus 3 plus 0 minus minus. Plus into minus minus. Last condition 3 to infinity. So 4 means 4 plus 3 plus 4 minus means plus. Again plus into plus. First and last because greater than or equal to 0. Therefore the q of x it belongs to belongs to minus infinity to minus 3, then union of positive 3 to infinity. So the condition minus infinity to minus 3. So this is the range. The last one 3 to infinity. This is the value. Already we found first one interval minus 2 to true. Minus 2 to true. Only this interval. So there is no connected term, isn't it? See, after finishing minus 2 and 2 also end. So in between divided by means each, and if you connected means we can take it the largest possible of real valid function. There is no connection. Therefore we can say f of x answer we have only null set, okay, or we can write it this symbol also, okay. Answer for there is no connector, therefore the null set, or we can write it this symbol also, okay. I will continue the next question. Question number 8. Find the range of the function 1 by 2 cos x minus 1. Solution. Already we know the cos x maximum to minimum value. The cos phi value minus 1 means cos 0 also positive 1. Therefore, maximum to minimum minus 1 less than or equal to cos x less than or equal to positive 1. So, minus 1 to positive 1. The condition into 2 is there, isn't it? So, each and every time into 2 means minus 1 into 2 minus 2 less than or equal to true cos x less than or equal to true. Then minus 1, isn't it? So, add minus 1. Minus 2 minus 1 less than or equal to true cos x minus 1 less than or equal to true minus 1. Minus 2 minus 1 minus 3 less than or equal to true cos x minus 1 less than or equal to 2 minus 1 positive. Then taking reciprocal, isn't it? So taking reciprocal, what will happen? Minus 1 by 3 means inequality symbol greater than or equal to again 1 by true cos x minus 1. So greater than or equal to 1 by 1 also 1 only will come. Then take it on number line. Minus infinity to positive infinity. Center 0 means 1, 2, 3 positive side, negative 1, negative 2 and negative 3. The condition, so the range means possible x values 1 by 2 cos x minus 1 greater than minus 1 by 3, isn't it? The greater than means this is the minus of the term means only this function, isn't it? It's moving to there. Then opposite side, this is if you take it means the greater than 1, isn't it? Listen, the 1 by 2 cos x, this is less than or equal to minus, the less than value, minus 1 by 3, negative side. At the same time, 1 by 2 cos x, this is greater than positive 1, greater than, more than positive value. Therefore, the range, first one, minus infinity to minus 1 by 3, isn't it? Minus 1 by 3, then union of, next continuation 1 to infinity open bracket. This is answer for question number 8, okay. Question number 9, show that the relation xy is equal to minus 2 is a function for a suitable domain. Find domain and range of the function. First consider for x set of value of set of possible value domain. Then y is considered for set of possible value range. Okay, the given term xy is equal to minus 2. Therefore, y is equal to minus 2 by x. So, what is the meaning of domain? So, all the real values possible except 0. Why I have written for except 0? If you take instead of x, the 0 means any number divided by 0 means not defined. Okay, that's why all the real values possible except 0. Next case, xy is equal to minus 2 means x is equal to minus 2 by x. There, sorry my dear, minus 2 by y. Therefore, range, here also all the real values possible except 0. Okay. So, except 0, here also instead of y, 0 means a number divided by 0 also not defined, it is not a function. That is why range all the real values except 0. Okay. I will continue next question. Question number 10. If f comma g such that r to r defined by f of x is equal to modulus x plus x and g of x is equal to mod x minus x, find f is composite of g and g is composite of f. Okay. Or we can say g dot f of x and f dot g of x. Solution, the first term. So, f of x is equal to mod x plus, already you know, what is the meaning of modulus of x? Plus or minus x, isn't it? Therefore, f of x less than or equal to 0. So, negative, no, negative means instead of x we can write it negative x, then plus x, then x greater than 0. Positive, no, then x plus x. Therefore, f of x is equal to minus x plus x cancel 0 when x less than or equal to 0. X plus x is equal to 2x when x greater than 0. So, next case, g of x is equal to, first condition is there, isn't it? What is the condition? G of x is equal to mod x minus x. Again, g of x is equal to x less than or equal to 0 means minus x. Here also one more minus x is there. Next case, greater than 0. So, x minus x. Therefore, g of x is equal to plus x minus x cancel means 0, x greater than 0, minus x minus minus 2x, x less than or equal to, there is only greater than 0. Now, the condition, first one, g dot f of x, isn't it? So, when x greater less than or equal to, isn't it? So, less than or equal to 0. So, less than or equal to 0 means g dot f of x is equal to g of f of x. Again, g of f of x less than or equal to 0. What the term is there? 0 only. You have 0. Therefore, g of x is equal to less than or equal to 0. G of x is equal to less than minus 2x. So, minus 2x means minus 2 into 0, value will be 0. Is equal to 0. Next one, f dot g, isn't it? F dot g of x. Again, f of g of x, f of. So, I will write it here. Confused, no? Wait dear, I will write this answer here. F of x is equal to 0, x less than or equal to 0, true x greater than 0. So, next case, f dot g of x is equal to f of g of x is equal to, so g of x less than or equal to 0, g of x less than or equal to 0 minus 2x, f of minus 2x. So, again f of x less than or equal to 0, f of x less than or equal to 0 only 0, therefore, value also 0 only. Next case, when x greater than 0, first condition, g dot f of x. So, g dot f of x is equal to g of f of x. Again, g of f of x greater than 0, f of x greater than 0, 2x. Again, g of x greater than 0, g of x greater than 0, 0. Therefore, answer also 0. Next case, f dot g of x. Again, f of g of x. So, f of g of x greater than 0, 0. Again, f of 0, f of x greater than 0, only 2x. Already 2x into 0 means value also completely 0. This is answer for question number 10. Question number 11. if f, g, h are real valid function on R, then prove that. Okay, this is we have to prove. I have taken for LHS. So LHS, the value f plus g dot, take it h of x means, what is the meaning? H of x means, so f dot h of x plus g dot h of x, isn't it? This is already definition 1.11, the product rule. F g of x means each and every time f of x into g of x. Similarly, we can apply f dot h of x plus g dot h of x. So this is how to rearrange it. Then if you remove the dot, the last question also, what is the meaning f dot g? G is composite of f means, if you remove the dot means the bracket. Therefore, if you remove the dot means we can take now f of h of x plus g of h of x, isn't it? Therefore, sorry my dear, similarly otherwise, already you know the point, isn't it? F dot g of x means, what is the meaning? F of g of x. Therefore, here dot is there. Now directly we can write now how? F plus g of, if you remove the dot means one bracket will come, f of h of x, isn't it? So now we can apply, this is x, this is whole term consider for x means f of x into g of x. What will happen? F of h of x plus g of h of x. So now just reverse order, if you remove the bracket means opposite dot will come, isn't it? Therefore, if you remove this, the bracket means f dot h of x, then g dot h of x. Therefore, both the term x is there. Now, if you remove means what will happen? Otherwise, what the term is there? F plus g dot h of x, isn't it? Here also what the term is there? H of x plus g dot h of x. So the common term x is there, no? Here x will be removed, x will be removed, x will, this is take common outside means definitely what the answer will come? F plus g dot h is equal to f dot h plus g dot h. This is our RHS term now. What is the term of RHS? F dot h plus g dot h. Then one more condition is given. What can you say about this value? Okay, what is the term is there? F dot g plus h is there, isn't it? So f dot g plus h. Take it outside means, again if you remove the dot means what will happen? F of g plus h of x. Again each and every time multiply into x means f of g of x into h of x. Again f of g of x, then plus f of h of x. Again if you remove the bracket means we can write now f dot g of x, again f dot h of x. Therefore, f dot g we can write now only except x means what is the term? F dot g plus f dot h. This is condition number 2. Therefore, from 1 and true, okay. This is RHS term. This is considered for equation number 1 means this is called equation number 2. So from 1 and 2 justify your answer. This is not equal. Now look at there. F plus g of dot h, value f dot h plus g dot h, isn't it? Therefore, f plus g of dot h not equal to f dot g plus h of f dot g plus h. This is not equal, isn't it? The condition will be proved now. Just if your answer means this is not equal, because equation number 1 right hand side f dot h plus g dot h, at the same time equation number 2 f dot g plus f dot h is there. Okay, I will continue next question.